Hello students, happy morning. Class 12 Physics, Unit 7, Wave Optics. In Unit 6, Ray Optics, we studied that light is an energy that transferred from one place to another and also it travel in a straight line. Then we discussed the phenomena of light in ray optics, that are reflection, refraction, dispersion and scattering of light. Here in wave optics, let me see the phenomenon that characterize the wave nature of light. Okay, that phenomenon that characterize the wave nature of lights are interference, then diffraction, then polarization. These are the phenomena that characterize light is a wave. Okay, let we see the theories of light that will say what is light. Okay, and also it explain the phenomena, theories of light. In theories of light, first of all, let we see the corpuscular theory that was proposed by Sir Isaac Newton. That is corpuscular theory. Corpuscular theory that was given by Sir Isaac Newton. In the year 1672. This theory explains the law of reflection and refraction. Okay, it explains law of reflection and refraction. According to this theory, light is a tiny massless particle. Okay, light is a tiny massless particle, massless elastic particle. That is called as a corpuscles. According to this theory, light is a tiny massless elastic particle that is known as corpuscles. These corpuscles are very small, so it does not suffer appreciable loss of mass, even it emit for a long time by a source. Okay, if a source emit a light, then the source does not lose its mass because the corpuscles emit by the source having less mass, that is a massless particle. Okay, then these corpuscles travel with the maximum speed, that is 3 into 10 power of 8 meter per second. Okay, so it does not affect by the gravity, so it travel in a straight line. Okay, if these corpuscles travel in a medium having a uniform refractive index, okay, if suppose it is a medium, this corpuscles, that means a light that travel in this medium, this travel with the same velocity in the medium of uniform refractive index. Okay, the energy of the corpuscles is given by the energy of the light that is given by the kinetic energy of the corpuscles. The light energy is given by the kinetic energy of these corpuscles. Okay, if suppose the corpuscles that fall on a retina of our eyes, that produce vision. Okay, corpuscles fall on retina of our eyes, it produce vision. Then one more thing this theory tells, that means the different size of the corpuscle that give different color. different size of corpuscles give different color. Okay, then this theory explain the reflection as if the corpuscles fall on a medium. Okay, if suppose the medium ripples the corpuscles, then there will be reflection take place. If a corpuscle fall on a medium, then the medium attract the corpuscles, then refraction take place. Okay, see, according to this theory, light is a tiny massless particle. Okay, that is known as corpuscles. It travel with the maximum speed, that is 3 into 10 power of 8 meter per second, so it does not affect by the gravity. These corpuscles travel in a medium of uniform refractive index in a straight line. The energy of the light is given by the kinetic energy of the corpuscles. Okay, if the corpuscles fall on a retina of our eyes, that produce vision. The different colors in a light, that is due to the different size of the corpuscles. Okay, if the corpuscles fall on a medium, that is a interface. Okay, if the medium ripples the corpuscles, then there will be a reflection, and if the medium attract the corpuscles, then there will be refraction. These are the statement given by Sir Isaac Newton in corpuscle theory about light. Okay, there is certain drawbacks are there. The drawbacks are, this theory could not explain the reason why the speed of the light is lesser in denser medium comparing with the rarer medium. Okay, and one more thing, it does not explain the phenomena such as interference, diffraction, polarization. Okay, there are two drawbacks. First drawback is, this theory could not explain the speed of the light. Why the speed of the light decreases in denser medium, and that is greater in rarer medium. And also it does not explain the phenomena interference, diffraction, polarization. Okay, then to overcome these drawbacks, the next theory came, that is a wave theory that was proposed by Christian-Huygens. Okay, to overcome the drawbacks of corpuscular theory, there is a theory given by Huygens, that is known as wave theory. In 1678, Christian-Huygens gave the theory called wave theory about light. This theory explained the propagation of light through the medium. Okay, this theory, it explains the propagation of light through the medium. Okay, according to this theory, light is a disturbance from a source. According to this theory, light is a disturbance from a source. Disturbance from source. So it is a longitudinal mechanical wave. Okay, light is a longitudinal, disturbance from source means it is a longitudinal mechanical wave. Mechanical wave. Okay, here this is a mechanical wave. We know mechanical wave need medium for the propagation. At that time, Christian-Huygens thought that there will be a medium in all over the space, that is named as ether. Ether is a medium spread all over the space. Okay, see, according to Christian-Huygens, light is a disturbance from a source, so it is a longitudinal mechanical wave. Okay, in order to compensate mechanical wave, okay, we know very well mechanical wave need medium for the propagation. So he is telling there is a medium spread all over the space, that is known as ether. In that medium this longitudinal mechanical wave spreads. Okay, this theory successfully explained the phenomena such as reflection, refraction, interference and diffraction. Okay, but later they thought it is proved that there is no any medium that present in a free space, that means vacuum. Okay, that means the existence of the ether in all space was proved to be wrong. Okay, due to this theory could not explain the propagation of the light through the free space or vacuum. Not explained the propagation of light through vacuum. Okay, because there is no medium in the vacuum. Okay, so it does not explain the propagation of light in vacuum. There are two drawbacks, that is, first one is it does not explain the propagation of light through vacuum. Second one is the polarization phenomena, that is not explained by the theory. Okay, the polarization was not explained by this theory. In order to overcome the drawbacks of wave theory, the next theory came, that is known as electromagnetic theory. Electromagnetic wave theory. In order to overcome the drawbacks of wave theory. Okay, here the electromagnetic wave theory that was given by Maxwell in year 1864. Okay, according to him, light is an electromagnetic wave. Light is an electromagnetic wave which is transverse in nature. Okay, according to wave theory, Huygens told light is a longitudinal mechanical wave, but according to Maxwell, he told light is a transverse wave, so it is a non-mechanical wave. Light is a transverse non-mechanical wave. This theory shows that no medium is necessary for the propagation of electromagnetic wave. Okay, and this theory explained all the phenomena of light such as interference, diffraction and polarization. But this theory could not explain the photoelectric effect. Not explained the photoelectric effect. Okay, this is the drawback of this theory. This was overcome by the next theory, that is quantum theory. Quantum theory. This was given by Albert Einstein. In the year 1905. Okay, here this theory explained the photoelectric effect. Photoelectric effect, that means if a light fall on a matter, that means a metal, okay, it produces electron, that is known as photoelectric effect. According to this theory, light having a particle called photon, having the energy E is equal to h nu. This is the energy of each photon, that each photon fall on a matter that emit an electron. Okay, this h is nothing but a Planck constant, minus 34 joules second. Okay, from this theory we conclude that light has both wave as well as a particle nature. Okay, so it is said to be a dual nature. From this theory we are concluding that light has a dual nature. It propagate as wave and it will interact with the matter as a particle. Light as a particle as well as wave nature. Okay, it propagate as wave and it interact with the matter as a particle. Okay, then let me see the phenomena that are interference, diffraction, polarization. Let me see first of all the interference and diffraction in wave theory and polarization in that electromagnetic theory. Okay, we know the wave theory. The wave theory give the explanation about the wave nature of the light. Okay, here by using this wave theory, let me see how to prove the law of reflection and refraction. Okay, for that first of all we need some basics. If suppose there is a still water, okay, if I drop a stone in that still water, it produce circular waves. Okay, these circular waves are known as circular ripples. Circular ripples. Okay, on that ripples there will be a particles. Okay, on each ripple there will be a particles. All the particles having a same phase of vibration and a same distance from the center. Okay, see each ripples having large number of particles or molecules. That particles or the molecules having the same phase of vibration and also from the same distance from the center of the stone. Okay, these ripples are known as wavefront. These ripples are known as wavefront. Okay, the wavefront, it is a locus. Locus means that position. Okay, the wavefront is a locus of points which are in same state of vibration, or we can say this one as it is a place where all the points are at a same phase of vibration. Okay, see wavefront is a, it is a locus, that is a position, locus of points on that curve. Locus means position or curve. Okay, on that curve there will be points, that points which are in same state or phase of vibration. Okay, this is known as wavefront. This wavefront is always perpendicular to the direction of the propagation of the wave. Okay, wavefront is always perpendicular to the direction of propagation of the wave. Waves. Okay, if suppose I consider a wave like that. Okay, this is a crust, this is a drift. Okay, if suppose this is a amplitude, if I drawn a plane, okay, this is known as wavefront. Here this is a wavefront, here this is a wavefront. Okay, these wavefronts that will be perpendicular to the direction of propagation. This is the direction of propagation, or this is the direction of the ray. So we can say wavefront is perpendicular to the direction of propagation or the ray. Okay, then let me see the shape of wavefront. Shape of wavefront. See this wavefront's shape that depends on shape of the source and distance between the source. Okay, it depends on shape of the wavefront. It depends on, first one is shape of the source. And the second one is distance at which the source is located. Okay, the shape of the waveform depends on shape of the source and the distance at which the source is located. First of all, let me see a spherical waveform. If suppose I consider a point source, okay, here first of all I consider a point source that is located at a finite distance. Okay, it give a spherical waveform. This point source that give a spherical waveform. See, the source is a point source. A point source is located at a finite distance. At a finite distance, gives spherical waveform. Okay, point source located at a finite distance give a spherical waveform. If suppose I consider a line source, extended line source, okay, it may be in a shape of a tube light. This extended line source that is located at a finite distance, okay, at that point we get a cylindrical waveform. We get a cylindrical waveform like this. Line source at a finite distance gives cylindrical waveform. The last one, any source, okay, it may be a point source or a extended line source, any source that are located at a infinite distance, okay, then we get a plane waveform. Then we get a plane waveform. Any source at infinite distance gives plane waveform. See, here first of all we discuss the theories of light. First theory is corpuscular theory. In that means Sir Isaac Newton considered light is nothing but a tiny massless particle called corpuscles. It having the maximum speed, so it does not affect by the gravity. Okay, and it pass through a medium of uniform refractive index. It travel in a straight line. The energy of the light is given by the kinetic energy of the corpuscles. If the corpuscles fall on a retina of our eyes, that produce vision. Okay, the different size of the corpuscles give different color. If the medium interact with the corpuscles, the medium attract the corpuscles, then will be a refraction. The medium repel the corpuscles, then there will be repulsion. Okay, then next wave theory. This was given by Huygens in 1678. This theory explained the propagation of light through medium. Okay, according to this, light is a disturbance from a source, so it is a longitudinal mechanical wave. It is a mechanical wave, so it need medium for the propagation. So Huygens told there will be a medium called ether that spread all over the space. Okay, but this theory could not explain the propagation of light through vacuum, because the existence of ether all over the space was proved to be wrong. Okay, then the next theory, that is electromagnetic theory, in order to explain the photoelectric effect. Okay, in order to explain the polarization. According to this, light is a electromagnetic wave with a transverse in nature, so it is a non-mechanical wave, so it need no medium for the propagation. It does not explain the photoelectric effect. In order to fulfill the photoelectric effect, next theory is given by Albert Einstein in 1905, that is known as quantum theory. According to this, light having a packets of energy, that is called photon, having energy h nu. Okay, this energy energized photon fall on a matter that emit electron, that is known as photoelectric effect. Okay, according to this theory shows that light is having a dual nature. Okay, it propagate as wave and interact with the matter as a particle. By the help of the wave theory, let we see what is interference, diffraction, polarization. Okay, the wave theory is given by Huygens. Okay, he told that if suppose if you drop a stone into a still water, it produces ripples. Okay, on that ripples there will be a particle, that particle having the same phase of vibration and all are at the same distance. Okay, that ripples are known as wavefront. These wavefront having a different shape. Okay, that depends on shape of the source and distance at which the source is located. Okay, if we get a cylindrical wavefront for a line source that are kept at a finite distance. Okay, if suppose we get a spherical wavefront for a point source located at a finite distance, we get a plane wavefront for any source that are placed at infinite distance. Okay, thank you.